Hello everyone, welcome to Gatewala. I hope everyone is well. So before I start the class, please do let me know whether audio video is okay to everyone or not. Am I audible? Am I visible or not? And most importantly, is there any sound issue? That buzzing sound, that unwanted sound is still there or not? Hello. Good morning, Anirudh. Everything is okay? That unwanted sound, is that sound still there? Okay, that means the problem is solved. Okay. So let's solve few questions based upon operators. So the very first question, easy one. Let us start with easy questions. Let's start with easy question. Let's start with one easy question. Tell me the solution. Tell me the solution. Tell me the answer. Good morning, Debrat. Good morning, Ananda Panda. Someone is saying answer is 1 and Manas is saying answer is 0. Amir is saying the answer is 1 and Manas is saying the answer is 0. Why it is so? Sir, we know that the priority of relational operator is more as compared to equal to operator. That means relational operator must be evaluated first. We have two relational operator. Because the associativity is from left to right, this one will be evaluated first. So tell me, 10 less than 5, is it true or false? Sir, this is false. Because this is false, the value associated with this is 0. Now we have a statement like this, d is equal to 0 less than c. Now 0 less than c, is it true or false? Sir, 0 is less than 4 is true. And that is why the value associated would become 1. So what is the value of d? Sir, the value of d is 1. I hope it is okay to everyone. We already discussed everything about these operators. We already discussed assignment operator, all arithmetic operators, relational operators, logical operators, short circuit evaluation, modify operator, 5 bitwise operators. Done. Done. Okay, let's solve. Don't worry about this. This is nothing, so don't worry about this. This is a typo mistake. So now tell me the answer. Manas, you have to remember them. You have to remember them. I can't help in that. I can help you in concept, but I can't help in remembering part. Sir, what is x? X is 0. So y becomes 0 ANDing with something. We know that when the first operand is 0, we need not to evaluate the second operand. Second operand would not be evaluated. That is why this printf will not work. And what is the result of 0 and something? The result of 0 and something is always 0. That is why the value that goes inside y is 0. So this Pankaj sir will not be printed, and that's why the result is 0. Now, what is the result? Now, what is the result? What is the output? Anirudh, don't worry about get ch. Forget. As of now, please forget this. Please forget this. It's my humble request. Please forget this. We will discuss about get ch in coming classes. As of now, don't worry about get ch. Don't worry about get ch. What is the answer? Sir, for this we have 5 and printf. Let me write it completely so that you will not do any mistake. Now, will compiler evaluate this? Of course, this will be evaluated. And because of this, on the output screen, Pankaj sir is to be printed. Of course, once it print its value, if I ask you about the value associated with this printf, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the expression becomes something like this. For AND operator, if both operands are non-zero, the result is true or 1. That is why, what is the value of y? The value of y is 1. But what does this /n perform? You Nitish Kumar, I didn't said that operator topic is complete. First of all, we are solving problem on what we have learned yesterday. I will discuss the remaining operators. Still, there are many operators which are remaining. Don't worry. I already told you yesterday that please don't write such comments. In every topic, no matter whether there is a doubt or no doubt, you have to comment. Don't show me your chatting capability, please. Okay, sir. Sir, what is the purpose of this /n? See, these all are called as sequence point. Sir, I'm sorry. Initially, the cursor is over here. Because of this printf, it will print PANKAJSIR and the cursor is over here. What is the purpose of this /n? This /n causes the cursor to move from current position to the first position in next line. So, if the cursor is over here, because of this /n, see, this /n is before printing. So when you execute this printf, the very first thing that happen is cursor will move from here to here. Go to the next line, to the beginning of next line. That is why this 1 will be printed like this. So don't think the answer is Pankaj sir 1. No, the answer or the output is Pankaj sir in one line and then 1 is printed in the next line. Is it okay to everyone? Is it okay to everyone? Is it okay to everyone regarding this lesson? Please reply fast. Anirudh Goyal, several time I told you, told students, but even if you ask me any book for C programming, if you are learning C programming the very first time, go for any standard book like Let Us See by Yashwant Kanitkar. But the approach to study a book, the approach to get knowledge from a book is start reading it from the first page and read it till last page. Don't skip any content, don't skip any page. Okay, done. Okay, tell me, we are just practicing logical or, logical and, nothing else. Nothing else. Tell me the answer. You, Nitish Kumar, you need to work really hard. Sir, sir, what is the value of x? The value of x is 10. If I ask you 10 or anything, what is the result? Sir, the result is always 1. Compiler will never evaluate. That is what we call as short circuit evaluation. This is called as short circuit evaluation. That is why this printf will not execute. This printf will not execute. And the result is 1. So what is the value that gets stored inside of y? The value that gets stored inside y is 1. Okay. Consider another option as none of these. Consider another option as none of these. So what is the answer? The answer is none of these. Is that okay to everyone? Is that okay to everyone? See, from answer don't change your concept. If the question is wrong, say it, sir, the question is wrong. Okay, let's try to solve question number 5. Let's try to solve question number 5. But before question number 5, let me introduce more assignment statements. Sir, 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 in this expression, what is happening? Actually, there are two operations being performed. If I am saying that the value of x is 10, if I say that the value of x is 10, then actually first we are increasing, we are adding 2 to x. First we are adding 2 to x. Okay, that means first, okay, now in second step, see, first we perform addition because arithmetic operator, and then whatever be the value, we are storing that value inside x. Am I right or not? So if I ask you, both the operation are performed on x or not? Sir, for addition x is needed, for assignment x is needed. So both operations need x as one variable. Okay, sir. Instead of writing it like this, in C programming, there is another way to write like this, and that is called as shorthand for. So the shorthand for this is x plus is equal to 2. Sir, which operation is performed first? Plus, and later on equal to. For plus, the operands are x and 2. For assignment, the operand is x. Is that okay? Try to understand it again. Try to understand it again. Sir, instead of writing it like this, in C programming, we can write it like this: x plus is equal to 2. Similarly, if I am having something like this, there is a shorthand for this is x minus is equal to 2. If I am having x is equal to x multiply 2, I can rewrite it like x multiply is equal to 2. Similarly, if I have x is equal to x divide 2, can I write something like this? Divide is equal to 2. Of course, sir. If I am having modulus operator, but remember, with mod, this and this must be integer. Then can I write it as x mod is equal to 2? Of course, sir. So these are called as shorthand. Each of them, although we are saying this is one operator, but actually it is a collection of two operators. Plus is equal to means addition, then assignment. Okay. Similarly, if I am left shifting the value of x by 2 and updating x also, I can rewrite it as something like this. So x right shift 2, you can rewrite it like this. Similarly, for bitwise AND, we can rewrite like this. Similarly, for bitwise OR, we can rewrite it like this. And similarly, for bitwise XOR, we can write it like this. So these are the new operators. That means the new operators are plus is equal to, minus is equal to, multiply is equal to, divide is equal to, modulus is equal to, left shift is equal to, right shift is equal to, bitwise AND is equal to, bitwise OR is equal to, and bitwise XOR is equal to. Done? Done? Now solve this question. Now solve this question. Now solve this question. Tell me, sir. See, the value of x is minus 5. The value of x is minus 5. We are saying p is equal to plus x. Because it is a pre-increment, first x is equal to x plus 1 will happen, and then p is equal to x will happen. So x is equal to x plus 1 will increase the value of x from minus 5 to minus 4, and p is equal to x. P is equal to x means the value of p becomes minus 4. Now because of this, because it is a post increment, first q will get the value of x, so minus 4, and then x is increased by 1. That means from minus 4 it becomes minus 3. From minus 4 it becomes minus 3. Okay. Now minus p says p is equal to p minus 1. So p becomes minus 4 minus 1, so minus of 5. So from minus 4 it becomes minus 5. Okay, sir. Now q plus plus will increase the value of q by 1, that is minus 4 plus 1. This becomes minus 3. Okay. Now p is equal to p plus q. P is equal to p plus q. What is the value of p? The value of p is minus 5 and the value of q is minus 3. So minus 8 is assigned to p. Minus 8 is assigned to p. Is that okay to everyone? Is that okay to everyone? Is that okay to everyone? So the answer is option E, because the answer is minus 8. Done? Done? Let's solve the next question. I am repeating again and again. Please forget this get ch. We will discuss about this later. Now, tell me the answer. Tell me the answer. See, there is no space between between not and equal to. If you put a space between not and equal to, compiler will not understand, because for compiler this becomes unary operator. If there is a space, then for sure there is an error. But there is no space. Okay? There is no space. If there is no space, how we would evaluate this expression? how we would evaluate this expression? Sir, the priority of the precedence of this is more as compared to not is equal to, and assignment operator is at lowest precedence. So first of all, 6 greater than 3 will be evaluated. Because this is true, the result would be 1. Now 1 not is equal to 0 is true. That is why the value that goes inside x is 1. So what is the result? Sir, the result is 1. Done? Done? Anirudh, I hope I already discussed that among relational operator, the priority of these 4 operator is more as compared to these operator. So the priority of this is more as compared to this. So how could this be evaluated first? Please don't repeat this mistake. Tell me the answer. There is no space. There is no space. There is no space. No error is there. Take it from me. No error is there. So tell me the output. Tell me the output. हो गया? Done? Sir, x is equal to 5 not is equal to 2 not is equal to 9 equal to 1 less than 5 not is equal to 0. Now what we know? Sir, coming to relational operator, the priority of less than is more as compared to not is equal to, double equal to, and assignment. The precedence is like this. So among all these operators, which one would be evaluated first? So tell me, 1 less than 5 is true or not? True, sir. If it is true, the value of this expression become 1. Now 1 not is equal to 0. Let me rewrite the remaining expression. We have 9 not 2 not is equal to 5 not is equal to x is equal to. Now we are only left with these operators, not is equal to, double is equal to, and equal to. So, sir, among all these, which one would be evaluated first? Sir, from left to right, whichever is coming first, because the associativity of these operator is from left to right. So from left to right, this one is coming first. That is why, tell me, is it true that 5 is not is equal to 2? Yes, sir. That is why the result is 1. Now we have 1 not is equal to 9, double is equal to 1, not is equal to 0. Okay. Now which one would be evaluated next? Sir, from left to right, this one is coming first. So 1 not is equal to 9 is again true. That is why the result is 1. Now 1 is equal to 1, not is equal to 0. Sir, among these two operators, the priority is same. That is why associativity says from left to right, this one is coming first. And because it is true, the result would be 1. Now if I ask you 1 not is equal to 0, is it true? Yes sir, it is true. That is why the answer is 1. So what is the output? The output is 1. Tell me the answer. Tell me the answer. Sir, see, not is a unary operator and its associativity is from right to left. So first of all, this is one error. Printf first of all, this not would be evaluated. In order to evaluate this not, printf must execute. So because of printf, Pankaj sir would be printed. And the value of this printf is, 6, 7, 8, 9. So now the expression is something like this. What is not of 9? Not of a non-zero value is 0. Now what is not of 0? Not of 0 is 1. And again not of 1 is nothing but 0. But because of this slash n, the cursor will move from here to here and the output is something like this. Pankaj sir in first line and in second line it is 0. Okay. Now, there are two operators remaining. Bitwise complementation. Bitwise complementation. Or you can say bitwise not. Or you can say bitwise not operator. that tilde sign is there. Before I'll discuss bitwise not, do we know how numbers are stored in computer memory? How numbers are stored in computer memory? Sir, there are many ways. The first way is signed magnitude. The first way is signed magnitude. For example, according to this, if I assume that number is of 8 bit, I am assuming if the number is of 8 bit, 1, 2, 3, 4, 5, 6, 7 and 8. For positive number, see, signed magnitude, what does that mean? Signed magnitude says that 1 bit is reserved for sign. 1 bit is reserved for sign. That is MSB, most significant bit. Most significant bit is reserved for sign. So if I wanted to store plus of 8, sir, the sign bit for plus is 0 and the sign bit for minus is 1. So try to understand. If we want to store plus of 8, sir, the sign bit becomes 0. The sign bit becomes 0 because it is a positive number. And the magnitude is represented in binary. So what is the binary of 8, sir? The binary of 8 is 1000. So if I ask you in 7 bits, how will you represent this 1000? Sir, 1, 2, 3, 1, 0, 0, 0. So the magnitude is represented by 7 bits and sign bit is 1 bit is reserved for sign bit. So can I say for plus 8, 1, 2, 3, 4, 1, 2, 3, 4, 0, 0, 0, 0, 1, 0, 0, 0. So in computer, plus 8 is stored like this. See, you all will learn this in your digital subject, but still I am trying to tell you whatever necessary. Okay, sir. But if someone asks me, then how I can store minus of 8? Sir, what is the sign bit for minus 8? What is the sign bit? The sign bit become 1. Coming to magnitude. Sir, we know that the binary of 8 is this. Magnitude in 7 bit would be this. See, I am considering everything in 8 bits. We are considering everything in 8 bits. You, Nitish Kumar, we can't write 129 in 8 bits. Don't ask such silly questions. We already covered range and all that in data type. Okay, so don't ask foolish questions. Done, sir. Okay, similarly, if I ask you how to store plus of 11, then plus says that the sign bit is 0. For minus 11, the sign bit is 1. Okay, what is the magnitude? Sir, we know that 11 in decimal can be written as 1011 in binary. So magnitude in 7 bits, see, these are 4 bits, so magnitude in 7 bit is something like this. So can I say plus 11 is nothing but 0, 0 0 0 1 0 1 1. Minus 11 would be stored. See, this is the sign bit, this is the sign bit, and this is the magnitude. Everything is good. Everything is good with this method. There is only one problem. There is only one problem. Sir, what is that problem? If I ask you that in 8 bits, if I write something like this, if I ask you what is this number, sir, for computer, how it evaluates? First, it will check the sign bit. Because the sign bit is 0, it says it is plus. Here, because the sign bit is 1, it says it here it is negative. Now coming to magnitude, sir, all are 0. That is why, try to understand. That is why for computer, sir, is it possible in mathematics? There are two zeros. One 0 is positive 0 and another 0 is negative 0. It will create lot of confusion. That's why initially the idea was to use this, but this will create unnecessary confusion. So the second way is using complementation method. So again there are two methods, one's complementation and two's complementation. But let me explain you two's complementation method. So numbers nowadays computer store negative numbers or store number in two's complementation format. Now what does this method says? Positive numbers are stored as it is. Positive numbers are stored as it is. That means in their binary form. Positive numbers are stored as it is in their binary form. Okay. And negative numbers, to store negative numbers, two's complementation is used. Negative numbers are stored in two's complementation form. Sir, for positive number, everything is okay. Just calculate the binary of that number, that will be stored in computer memory. For negative number, you need two's complementation format. That means if I talk about this two's complementation method and considering 8 bits integer, if someone asks me to store plus 11, I will calculate the binary of 11. So remainder 2, quotient 5. What is the remainder? If I divide 5 by 2, I'll get the quotient as 2, remainder 1. If I divide 2 by 2, I will get quotient 1, remainder 0. If I divide 1 by 2, I will get the quotient 0 and the remainder 1. Sir, the binary for 11 is 1011. So if someone is saying in 8 bits, so can I say that plus 11 is nothing but 0 0 0 0 1 0 1 1. Tell me, is that okay? Is that okay to everyone? Is that okay to everyone? Is that okay to everyone? Reply very fast. Please reply. See, please solve DPP properly. consistently solve all DPPs. The DPP questions are designed very well, very well. They are designed in very good way so that you will learn all the concept while solving the DPPs. So don't skip any DPP. Done, sir. Now, sir, I wanted to store -11. So what is the procedure? It says, try to understand. Find the binary of +11. Find its ones complement. Or directly, let's try to do. Find its twos complement. And store it. That means in order to store -11, tell me what is the binary of +11? Sir, we just calculated it. Okay. Now I need to calculate the twos complementation of this number. The twos complementation of this number. See, there are two methods to calculate the twos complementation. First method says find ones complement, and then add 1 to ones complement. And there is a direct method. There is a direct method to find twos complement. So let's see both of them. Sir, what is the ones complement? Ones complement says just flip all bits. That means 0 becomes 1 and 1 becomes 0. 0 becomes 1 and 1 becomes 0. So if I wanted to find -11, first we find the binary of +11, which is 0 0 0 0 1 0 1 1. Now let's try to find the ones complement of this number. So tell me, sir, this 0 becomes 1, this 0 becomes 1, this 0 becomes 1, this 0 becomes 1, this 1 becomes 0, this 0 becomes 1, this 1 becomes 0, this 1 becomes 0. Is that okay to everyone? Is that okay to everyone? Is that okay to everyone? Sir, this is the ones complement. If I add 1 to it, I will get the twos complement. So 0 plus 1 is 1. Sir, then 0, 1, 0, 1, 1, 1, 1. Done to everyone? Done to everyone? See, if you don't know addition, tell me, if there are 2 bits, 0 plus 1, sir, it is 1. If it is 1 plus 0, it is 1. If both bits are 0, it is 1. Now understand, if I add 2, 1, it becomes 1, 0. Sir, in binary, this is 2. In binary, this is 2. That means, sir, 1 plus 1 is nothing but, see, if I ask you 9 plus 1, you will say 10. That is, this is the sum and this is the carry. Same concept in binary. If 1 plus 1 is 2, so 1, 0. So 0 is the sum and 1 is the carry. Although we don't need it over here. Done to everyone? Done to everyone? Sir, this is twos complement. This is twos complement of this number. Do we know how negative numbers are stored? Now the big question is, if I show any number to computer, how computer gets to know whether it is negative or positive? See, what we know, we store a number inside memory. Okay, that part is over. But if we fetch a number from memory, how computer evaluate whether it is negative or positive? Try to understand. Sir, notice the fact that, sir, can we calculate the value of a 2's complement number? Sir, in 2's complement, if you wanted to find the value, only focus on zeros. Focus on zeros. Sir, we have 1 1 1 1 0 1 0 1. Sir, it is 2 raised to the power 0, it is 2 raised to the power 1, it is 2 raised to the power 2, it is 2 raised to the power 3, it is 2 raised to the power 4, it is 2 raised to the power 5, it is 2 raised to the power 6, it is 2 raised to the power 7. See, in binary number, we focus on 1. But because 2's complementation is obtained by flipping, see how we get 2's complementation? By flipping bits. That means by 1's complement, then add 1. So if I wanted to find the actual value, what is the number over here? Just focus on 0. Sir. 0, 0. We have minus 2 raised to the power 3. See, why minus? Because I know that this number is negative. Okay. And there is another 0 at minus 2 raised to the power minus 1. And add a minus 1. Why this minus 1? See, the process is reversed. How we get 2's complementation? 1's complementation plus 1. 1's complementation plus 1. Is that okay? So try to understand. First, let me find the value. Isn't it minus 8 minus 2 minus 1 minus 11? Isn't it minus 8 minus 2 minus 1 minus 11? Yes, sir. Now try to understand. Sir. Computer again only check this bit. Computer again only check this bit. Although there is no sign bit, but computer, by only looking at this number, judge the sign of the number. That means if I show any number, to computer, how computer evaluate? Computer will see the MSB, put a negative sign, and understand that this must be written in 2's complementation. In order to find the value, what we can do? Either find the 2's complementation again, or use the direct method I provided. Sir, can I find the 2's complementation of this number? Can I find the 2's complementation of this number? Tell me, what is the 2's complementation of this number? Sir, first find the 1's complementation. 0 0 0 0 1 0 1 0. This is the 1's complementation. If I add 1, again this becomes 0 0 0 0 1 0 1 1. So, sir, this is nothing but 11. So computer gets to know that the number is minus of 11. Done. Second way. Sir, 1 1 1 1 0 1 0 1. Sir, by looking at this, computer gets to know that the number is negative. But in order to find this value, don't complement it, just focus on 0. So what we did? Said 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. There is no 0. So how can I find the value? Sir, try to understand. Sir, don't put any sign. Computer gets to know that this number is negative, and because the number is negative, it must be present in 2's complementation form. Sir, can we find the value of a number directly? Yes. Once you get to know that this is written in 2's complementation form, just focus over here. Because the number is negative, everything is negative. Because the place value is 2 raised to the power 3. Okay. For this 0, the place value is 2 raised to the power 1. Add extra minus 1. So what is the value? Minus 8 minus 2 minus 1. So it is minus of 11. Done to everyone? So tell me, if I give you this number, and ask you, find the value. Tell me the value. Is everything okay? Okay, okay. The chat was not working properly. Okay. Sir. What is the number? Tell me. Tell me the value. Tell me the value. Sir. By looking at this one, we understand that this number is negative. So how to find the value? Sir, this must be written in 2's complementation form. This must be written in 2's complementation form. How to find the value? Only focus on zeros. So 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. So what is the value? Minus of 2 raised to the power 3, minus of 2 raised to the power 2, minus of 2 raised to the power 1, and put an extra minus 1. So it is minus 8, minus 4, minus 2, minus 1. If I am not wrong, it is minus of 15. Am I right? Am I right? Am I right? So now let's understand. The operator tilde. Actually, it is nothing but it performs the ones complementation. It performs the ones complementation. So let's try to understand. If I write something like this, that int a is equal to 5, int a is equal to 5, comma b, and if I perform b is equal to ones complementation of a and try to print the value of b, what is the answer? Or for more understanding, let me take a bigger value. Let me take a value like 48. Sir, because we are working on bitwise operators, let me find the binary of 48. What is the binary of 48? Tell me. 16 and 32. That means 0, 0, 0, 0. We have a 1 for 16. We have a 1 for 32. 0, 0, 0, 0, 0, 0. And there are 4 more zeros. Is it okay? Is it okay? Is it okay? Done. Sir, what is the complementation of 48? Because it is one's complementation, 0 becomes 1 and 1 becomes 0. Done? Done, sir. That means this is B. Now, this number is stored in computer memory. This computer is stored in computer memory. And if I ask you, what is this number? How will you find out, sir? Only by looking at this, we can say that this number is written in 2's complementation form. And because this number is written in 2's complementation form, there are two ways. First way says just find the value using a direct method, or again find the 2's complementation of this number. There are two ways. Okay. Which way you want? It? Sir, direct method says, see, we have 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6, and so on. Okay. So coming to this 0, this is at 2 raised to the power 4 and this is at 2 raised to the power 5. So can I say the value is minus 2 raised to the power 5 minus 2 raised to the power 4 minus extra 1. Done. Can I write it like this? Minus of 2 raised to the power 5 plus 2 raised to the power 4 plus 1. Yes, sir. What is the actual number? Sir, the actual number was, please try to understand, the actual number was 2 raised to the power 5 plus 2 raised to the power 4. Am I right? Am I right? Isn't it minus of a plus 1? Of course, sir. Sir, The number A was this, isn't it? Can I say that the complementation of A is nothing but minus of A plus 1? Can I say this or not? I discussed all this just to say how the result of complementation of A comes to be like this. I discussed all the entire concept for this, just for this single line I derived everything. Is it okay to everyone? Tell me, is it okay to everyone? Is it okay to everyone? I'm not able to view your chat. I hope the chat is not working. Can someone personally message me whether everything is okay or not? Am I audible or not? Okay. So for complementation operator, now what we know, sir, the result is minus of A plus 1. So if someone says that int A is equal to minus of 5, if I try to print the complementation value of A, sir, what would be the result? What would be the result, sir? The result would be minus of A plus 1. The value of A is minus 5. So minus of minus 4, the answer is plus 4. So what is the answer? The answer is plus 4. So that's about complementation operator. Now we know what is complementation operator. Do we know more assignment operators? Yes, we know assignment operator. Okay. So let's understand the next operator called as ternary operator. The only operator in C language that takes 3 operand as an argument. The only operator that takes 3 operand, sir, also called as conditional operator. How? Sir, the syntax is something like this. Expression 1, question mark, expression 2, colon, expression 3. Sir, before question mark, expression 1 is there. After question mark, before colon, we have expression 2. After colon, we have expression 3. How this operator works? First, expression 1 is evaluated. Expression 1 is evaluated. Expression 1 is evaluated. Now, what we know about expression? Sir, the expression 1, either it can be true or false. What is true? Non-zero. Or it could be 0. Am I right or not? Of course. The value of an expression can be non-zero or it can be zero. Done. Non-zero means true. 0 means false. So what we are saying, if expression 1 is true or non-zero, the result or value of this entire operation, the result or the value of this entire expression is equal to expression 2. If expression 1 evaluates to false or 0, then the result or value of this entire expression becomes equal to expression 3. Let's see, sir. If I ask you something like this, that 10 greater than 7, question mark 10 colon 7. Sir, in this, first 10 greater than 7 would be evaluated. Is it true? Yes, sir, it is true. Because it is true, the value of this entire expression becomes equal to 10. That means, what is the value that goes inside max? The value that goes inside max is 10. Actually, this is nothing but to find the maximum among 10 and 7. The maximum among 10 and 7. Done, sir. Similarly, it could be anything. If I ask you something like this, A is equal to tell me the answer. Tell me the answer. Sir, first of all, this printf, because this is expression 1, this is expression 1, this is expression 2, this is expression 3. So first of all, expression 1 evaluates. That means 1 would be printed. But what is the value of this printf? Sir, this becomes 1 question mark printf 2 colon printf 3. Now tell me whether this is true or false. Because this is true, the value of this entire expression becomes printf 2. That means, can I say something like this, that A becomes printf 2. Okay, what is the result? Sir, this will print 2. And because this printf printed only one character, the value of this printf is 1. That is why the value that goes inside A is 1. And again you are printing A. That is why the result is 1 to 1. You know na? Anna 24 ghante chaukanna. Every programmer must be so much attentive. So much attentive. Done to everyone? Done to everyone? Done to everyone or not? Now let's solve this question. Now you know everything. Now you know everything. Tell me the answer. Solve it with utmost care. Focus on all operators and what could be the possible result. Tell me the answer. Nine. Manas is saying 9. Sayan Datta is saying 9. Okay. Okay, tell me, sir, what is the first expression? 5 or 2, bracket is there, greater than negation of 0, question mark 9 colon 10 left shift 2. Sir, before question mark we have expression 1. So can I say this is expression 1? Between these two we have expression 2. Can I say this is expression 2, 9, and this is expression 3? So first we need to solve expression 1. Is there any problem? Okay, greater than. Sir, first of all, bracket will be solved. Tell me what is the value of this? Sir, what we know is minus of 5 plus 1. So it is minus of 6. So we have minus 6 bitwise ORing with 2. Minus 6 bitwise ORing with 2. Okay. Greater than negation of 0. Okay. First, what is minus 6? Sir, first you will find plus of 6, which is 1, 1, 0. Let's take everything in 8 bits. This is plus of 6. To find minus of 6, we need to take the 2's complementation of this. Sir, first we find the 2's complementation. How we can find the 2's complementation? Sir, there are two ways. First, find the 1's complementation. Find the 1's complementation. It becomes 1, 0, 0, 1, 1, 1, 1, 1. And then add 1. Am I right? Am I right? Done, sir. So if you add 1, to it, sir, 1 plus 1 becomes 0 and 1 carry. 1 and 0 become 1. Then 0, 1, 1, 1, 1, 1. Am I right or not? Sir, this is 2's complementation. This is how minus 6 is stored. Sir, is there any method to find 2's complementation of a number? Let me find the 2's complementation directly. I am finding 2's complementation directly. How to find? Move from right to left until first one is encountered. Move from right to left until first one is encountered. Just write everything as it is. Once first one is encountered, then flip all the bits. So 1 becomes 0 and 0 becomes 1. Are they same? Are they same or not? Are they same or not? Yes. Again, let me tell you everything again. Sir, if someone tell you to find the 2's complementation of, this, there are two methods. First, find 1's complementation, which is 1, 1, 1, 1, 1, 0, 0, 1. And then add 1 to it, which is 1, 1, 1, 1, 1, 0, 0, 1. Add 1 to it. We can find, sir, 0, 1, 1, 0, 1, 1, 1, 1, 1. This is the first method. Second method says, move from right to left. Move from right to left till first one is encountered. Write everything as it is. After this point, flip everything. So 1 becomes 0 and all zeros becomes 1. Are they same? Are they same? Yes, sir. So any of the method can be used to find the 2's complementation of a number. Okay. So from 2's complementation, we can find the value in two ways. 2's complementation can be found in two ways. Just focus on what you understand, sir. So minus 6, the value of how minus 6 is stored? 1, 1, 1, 1, 1, 0, 1, 0. How 2 is stored? 1, 0, 0, 0, 0, 0, 0, 0. If you perform the ORing, if you perform bitwise ORing, you will get 0, 1, 0, 1, 1, 1, 1, 1. If I am not wrong, it is same as minus of 6. Okay. That's why it becomes minus 6 greater than, what is complementation of 0? Complementation of 0 is nothing but minus of 0 plus 1, which is minus 1. So now tell me whether it is true or false. Tell me whether it is true or false. Tell me whether it is true or false. Everyone is wrong. For this question, everyone is wrong. Sir, now tell me, is it true or false? Sir, this is false. Because this is false, because this statement is false, the value of this entire expression become expression 3. So can I say x is nothing but 10 right shift 2 time? Now 10 right shift 2 time is as same as 10 into 2 raised to the power 2, which is 10 into 4. So can I say the answer is 40? Can I say the answer is 40 or not? Can I say the answer is 40 or not? Can I say the answer is 40 or not? How many of you are wrong? Is there anyone who predicted the answer correct? Is there anyone who predicted the answer correct? Is there anyone who predicted the answer correct? Tell me na. Is there anyone who predicted the answer correct? Is there anyone? Good. Let's solve this question. Tell me, sir, error. I intentionally write this. Sir, computer don't understand 10z. It is okay in mathematics, but in computer programming, it is not okay. You have to tell that it is 10 into z, because in mathematics, if there is nothing between two values, we consider it as multiplication. But for computer, you need to provide everything. Computer don't have any brain. So, error is there. Now, sir, forget this part. Can I remove? No, of course I cannot. So consider this as q is equal to 10 into z plus p minus 2 into q. And then solve this question. Now tell me the answer of this question. Of course, int 5 will also create an error. It must be int x. X is equal to 5. Of course, x is equal to 5. It is nothing but int x is equal to 5. It is nothing but int x is equal to 5, comma y is equal to 10. Now solve it. Nivedita, x is defined. Okay. That's a typo mistake. Please solve it carefully. What is the answer? Let's understand it. Okay, sir. X less than equal to y. 5. No, no. 5 less than equal to 10. Is it true? Yes, sir, it is true. Or do we need to evaluate this? No, sir. Do we need to evaluate this? No, sir. Never evaluated. Because this is true, Z will get a 1. Z will get a 1. Okay. Now, X less than Y is still true. X less than Y is still true. Okay. X less than Y is true. X equal to Y is false. That is why true and false. So what is the value that goes inside P? P becomes 0. Now, because of bracket, if I ask you X less than Y, again it is true, and X not is equal to Y, again it is true. That is why all these brackets, the answer is 1. So now Q is nothing but not of 1. So not of 1 is nothing but 0. Now not of 0 is 1. So what is the value of Q? The value of Q is 1. Now if I ask Q is equal to 10Z, so Q is equal to 10 into 1 plus 0, the value of P is 0, minus 2 into, what is the value of Q? 1. So if I am not wrong, the answer is 10 minus 2, the value of Q becomes 8. Easy question. I hope everyone must have cracked it. You all can do this. You all can do this for sure. Easy question. Try this as a homework. Sir, before this, you need to understand comma operator. I will discuss comma operator in last lectures. Understand this. Now tell me the result. Tell me the result of question number 15. Tell me the result of question number 15. Tell me the result of question number 15. Easy one. If X is 12 and bitwise ending with 1, 12 is 1100, bitwise ending with 1, sir, this becomes 0000, so this result becomes 0. If this becomes 0, the value of this entire expression becomes this. That means printf will work and the result would be gate. Don't say gate 4. Arey, how 4 would be printed? There is no printf statement. That is why the output of this statement is gate. Don't say output is gate 4. We are not collecting the value of printf anywhere. No, we are not collecting the value. Okay, tell me a question. Tell me a question. What is the result of this? Okay, expression is false. Sorry. My mistake. Because the expression is false, the result is equal to expression 3. So 2023 is the right answer. I apologize. Sorry. I thought it was true. Sorry. I apologize. I take it as true. That's my mistake, totally my mistake. Done to everyone? Done to everyone? Thank you, Nivedita. Thank you. Sir, what is the result of this? What is the result of this? How printf will work? How printf will work? How printf will work? Sir, first of all, this statement must be evaluated, na? First of all, this statement must be evaluated and then printing is performed. Okay. So whatever it is, sir, first of all, 1 plus 6 minus 4, then 7 minus 4. That means first of all, this expression is evaluated, then this percentage D will work. So expression is evaluated first, then because of percentage D, integer value is to be printed. Okay, sir. Sir, how it will work? Sir, forget everything else. For this percentage D, isn't it the expression? We wanted to print the value of this expression. We wanted to print the integer value of this expression. So just like previous question, first this expression would be evaluated. Am I right or not? Of course, yes. Now that means for this printf, first this printf need to be evaluated, and for this printf, first this expression need to be evaluated. The value of this expression is 3. So once you solve it, this expression becomes printf percentage D comma 3. How many symbol this printf printed? This printf printed only one symbol, which is 3. So can I rewrite this? Can I rewrite this like this? Printf percentage D comma 1. Can I rewrite it like this? Of course. So now the outer printf will print 1. Is it okay to everyone? Tell me, if I write something like this, sir, what is the result? Sir, what is the result? Tell me the result. Nivedita, please cross check. Nivedita, please cross check. Nivedita, beta, please cross check your result. Sir, first of all, this expression would be evaluated. Within this expression, this printf would be evaluated. That is why gate would be printed. Then printf 2023 execute. That is why 2023 printed. What is the value of this printf? The value of this printf is 4. What is the value of this printf? The value of this printf is also 4. Now, if I ask you if I ask you to print something like this, tell me what is the result? Sir, the result of this is 1 because it is true. That is why this printf prints 1. This printf prints 1. Is that okay? This printf print 1. Because this printf printed only one symbol, what is the value of this printf? The value of this printf is also 1. So what is the value that goes inside A? The value that goes inside A is 1, and because we are printing the value of A, the result is 1. Done to everyone? Done, sir. Now there is another operator called as size of operator. There is another operator called as size of operator that tells you the number of bytes the memory, some expression, some data type or some variable is taking in storage area. Sir, for example, first it is a unary operator. The very first thing you need to understand is it is a unary operator. Okay. Second thing, it is compile time operator. It works at compile time. That means no need of execution time. Size of operator store the result even at compile time. That means nothing at execution time for size of operator. Try to understand. Sir, if I assume that I am working on a compiler in which short take 2 bytes, int take 4 byte, float take 4 byte, double take, I am assuming all this. Okay, I am assuming all this, that 2448, I am assuming all this. Okay, so now if I ask you what is the size of, if I provide this information, if I ask OS size of, what is the size of short? If we are working on a compiler where the size of short is 2, what is the answer? Sir, it will produce the answer as 2. If I ask size of, what is the size of character on this system? It will give 1. If I ask size of, what is the size of int? It will give 4. For sure, sir. Everything is okay. Now tell me, is there any possibility that size of can give negative value? No, sir. How could the size inside a memory can be negative? That means one thing is for sure. What is the value associated with size of operator? It will always provide unsigned integer. Size of operator always give the answer as unsigned integer. Size of operator always gives the answer as unsigned integer. I am not saying that size of operator does not work on signed. I am saying what is the answer of size of. Size of can take negative value, of course. If sir, size of -4. See, -4 is an integer and integer occupy 4 byte. So the result is 4. Size of 2. So 2 is an integer and the size of integer is 4. That's why the size is 4. Now, if someone asks me, sir, what is size of, if someone asks me what is the size of 3 plus 4, tell me what we studied in operators. Sir, 3 is an integer, 4 is an integer, and we know integer plus integer is an integer. So tell me whether we need to execute this statement 3 plus 4 or at compile time size of operator can manage the things, because Size of operator knows that integer plus integer, the result must be an integer. And what is the size of integer? It is 4. So can I say the result would be 4? Try to understand. So for size of, sir, size of is a unary operator. So what could be the operand for size of? Sir, is it possible to provide a variable? Yes. For example, you can write something like this: int I. Can I ask size of O is size of, what is the size of I? I hope you must remember why I am using percentage U, because the result of size of is a unsigned integer. Now, because I is a variable of type int, size of know that the answer is 4. Do I need to execute anything? No, sir. Sir, can it be an expression? Can it be an expression? Of course, it can be an expression. For example, we can ask size of, O is size of, tell me 1 plus 3 into 2. Size of knows because all are of type integer. See, the result is integer. Integer plus integer is an integer. So size of will provide you the answer as 4. Of course, sir. Can it be a literal? For example, expression, you can think of expression like this also. If I'll say int A is equal to 10, B is equal to 5, sir. See, these are all constant. Expression does not always mean constant. Sir, can I write A plus B into 2? Yes, of course, it is an expression. Again, B into 2 is an integer. Integer plus integer is an integer. And because we are working on a compiler in which size of integer is 4, that means everything is okay. Now, is it possible to have a literal over here? We already know this. Printf %u, comma, size of 4. Of course it is possible, because 4 is an integer and integer occupy 4 bytes. That's why. Done, sir. Sir, can it be a data type? Can it be a data type? Of course. Of course it can be a data type. So you can write something like this: printf %u, comma, size of int. So our integer is of 4 bytes. Done. Now let's understand few important points about size of. Sir, are parentheses mandatory? Are parentheses mandatory? No. Sir, expression without parentheses, okay. Literal without parentheses, okay. Variable without parentheses, okay. That means, sir, if you write something like this or you write something like this, both are okay. If you are writing something like this, 4 plus 3 into 2, or you are writing something like this, there would be no error. That is another thing, that what is the result. That is another thing, that what would be the result. Okay, sir. Now try to understand. But sir, for data type, parenthesis is mandatory. For data type, parenthesis is mandatory. This is invalid. For data type, parenthesis is mandatory. Manas, you tell me what is the result. Manas is saying, sir, char A, comma B. Manas, I hope we know that whenever plus or any arithmetic operator is there, the integer value of a character is considered. The integer value of a character is considered. That means, sir, actually integer is there. That is why integer plus integer, the result must be a integer. That is called as typecasting. We will discuss it later. Don't worry about that. Manas, you get your doubt cleared or not? Manas, is that okay to you? Manas, everything clear? Manas, did you get your doubt cleared? See, there are many questions just for homework. Just for homework. Please ask me in case you are having some doubt in any of the question. Please don't try these questions based upon comma operator, because I will discuss comma operator separately in my last class of C programming. Manas, of course. Please solve it carefully, and in case of any confusion, feel free to ask. So tell me, is there any doubt remaining regarding operator, regarding size of or any operator? See, with time, you will get to know the priority and associativity. Once you try to solve questions like this, automatically the priority and associativity somewhere sits inside your unconscious mind. Any confusion? Any confusion? Is there any confusion? Nitish, in doubt section, please ask your doubt over here. Nitish, please ask your doubt over here. I am standing over here. Don't propagate your doubts. If you know my Telegram number, please feel free to ask doubt over there also. So you all are getting confidence in operators or not? You all are getting confidence in operators or not? Okay, let's solve one last question. Let's solve one last question. One last question for everyone. Last question for everyone. Answer it quickly. Okay. Please solve it. We will discuss this in coming class. And the next class is at 2 p.m. The next class is at 2 p.m. I will discuss this question over there. Okay. So, bye-bye. Take care. Let's meet on. Everything is okay or not? Sir, if possible. Everything is okay? So the timing for next class is 2 p.m. Bye bye. Take care.